Alright, in this video, I'm going to talk about the concept. This is the part 1 video. I'm talking about the concept of limits at infinity. It's different from limits. It's different from infinite limits. Infinite limits means when you're approaching a value, you're getting an infinity here. So, but now is when the x value is getting very big. Limits at infinity means that the limits when the value of x here, the input is getting very big. The limits at infinity. So it will produce, okay, we need to know what is the outcome here. Is it a number? Is it infinity? Or is it undefined, right? So negative infinity, what happened when it's a very negative, big negative value here? So what is the value of these limits? So this is called limits at infinity. Alright, so let's look at the concepts here. So for example, if I have limits, if I say that limits of x approaching a very big number, right? A very big number, for example, x plus 1, right? So when x is a very big number, what does it mean by approaching very big number? Means that x is something like a very big number. Wow. I don't know how big is it because infinity is undefined, right? I don't know what is infinity. I don't know how big is it. So it's never defined, any number. So it can be very big. So a very big number plus with 1, you are still getting infinity, right? For example, you have 1 billion. You have $1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you have 1 billion. I give you a 50 cent. I give you 50 cent. Are you still considered rich? Right? You are still rich. You are very rich. You have 1 billion 50 cent. Right? But this value is insignificant for you. You may say 50 cent for me. I can donate to others, right? Because me is very rich, I very rich, so I will be positive infinity, right? So 50 cent for you is like insignificant, nothing, right? So 1 billion plus with 0.50 cent, you are still a very big number here. So then, what if? So this is a concept. This is a concept. So I hope you understand the concept of infinity, right? So, for example, if I have limits of x approaching positive infinity, but now it's x minus 1, right? What is the value? You think first, then you pause the video, you think first, what's the value? So now, okay, a very big number, for example, I have 1 billion. 1 billion, a very big number, it can be more than 1 billion, very big, okay, the value is very big, very big, okay, infinity. So if you go and minus 1, you are getting like 9. But is this number considered very small? No, it's still a very big number. Means that the infinity, you can ignore the negative 1 as well. So means that x minus 1, the negative 1 here is insignificant at all. So you are still getting positive infinity, right? Positive infinity, very big. You minus 1 also, it will be a very big number here. So, okay, so I'm giving you more cases. So now, for example, if I have limits as x approaching positive infinity, for 1 minus x to the power of 2. So can you consider intuitively, you understand inside your heart, with your mind, what is the outcome here, right? We said limits at infinity. So when you said, imagine in your mind, this is in your mind, don't write it out, okay, in your mind. Now in your brain now, you have 1 minus infinity square. Wow, infinity square is a very big number. You already very big. This number is already very big number. You go and square, right? You go and square. The number even bigger, right? Even bigger. So 1 minus a very big number. Minus a very big number. So of course, you're taking a smaller number minus with a very big number, you are getting a negative number. but it's a negative big number, right? 1 minus this one, 1 minus, for example, 1 minus 1 billion. You are getting negative big number, right? Negative infinity, right? So this is the concept of infinity, a basic concept for infinity. So now, for example, if I have this type of cases here, so you jot down whatever I tell you now. So if I have a case where limits as x approaching negative infinity, for example, for 1 over x to the power of 3, x to the power of 3, minus with 2, minus with 2. So, question mark, right? So, this you should think for yourself, okay? You should think about it, all right? This is a concept. You must mathematically enough to understand this concept. So, for example, negative infinity, right? Negative infinity. So, a number, for example, okay, let's look at, I will give you some example. Alright, let's see. So, what happened, right, for these cases here? So, I was asking you, okay, 1 over 10. 1 divided by a very big number, you're getting 0.1, a smaller number, right? So, as you're getting bigger, the denominator getting bigger, you're getting smaller number. As you divide by 1000, it's getting 0.001, which is very near to 0, right? If you divide by 1 billion, can you imagine 1 billion you divide? How many zero you have? You will have many zero, right? This one, if you round off, you're getting 0, right? Very near to 0. Mean this whole thing is near to 0. Alright? It's nearing to 0. So, in the previous video, I talked about infinite limit. It's very different. It's divided by a very small number, right? A very small number. This is I divide a very big number, right? Divide a very big number. The smaller the number, the bigger the outcome, right? So 1000, right? This is infinite limit. So now I talk about limits at infinity. So now what happened to this? When this negative infinity is substituted inside here, imagine you divide by an infinity. As you see here from here, 1 divided by a very big number, it will be approaching 0, near to 0, or I can consider this to be 0. So very simple. The simple way to think about this is, when a number divided by an infinity, you are approaching 0. This one can consider to be 0. So, of course, if this one near to 0, then the outcome will be negative 2, right? You still have negative 2. It's approach to negative 2. So, now, this is the way we evaluate the limits at infinity. So, I give you some cases again now. Alright? So, for example, if I have alright. For example, I can asking you, what happened when I evaluate x approaching negative infinity of a square root of 4 minus x9, right? So what happened when you evaluate limits? Can you pause the video and try to write down your answer before you're watching what is happening to the outcome? So, okay, now you can see that. Imagine in your mind. So we have square root, right? 4 minus x. X is a negative big number. So you can put negative 1. Very big number lah. Any number, right? Because infinity is undefined. You can be, sir, why you always using 1 billion? Why don't 1 trillion? Why not 900,000? Anything. It's a very big negative number. I have tell you, negative, any negative big number. So what happened when you have negative here? You minus 4 minus, you're getting positive, right? getting positive. Means 4 plus with a very big number, you are still getting a very big number inside there, a very big positive number. So as you square root of a very big number, you're still getting a very big number. This is to tell you that the infinity is something that very big. It's a very large number, such that when you square root, you're still getting infinity. Alright, so okay, one more. I want you to become a thinker. Okay, you have to think. So what happened when you have positive infinity? 4 over x plus 2 minus x. If you can answer this one correctly, you are great. Okay, you are a mathematician. So now you try to answer this. Alright, what's your answer? Let's look at this. So 4 over x plus 2 minus x. What happened when x very large value? Wow, very large. So when infinity plus 2, very large number. This is a very big number here, right? Very big number. When you take infinity plus 2, it's a very big number. A number divided by a very big number. I have tell you just now, as the number getting bigger and bigger, you are getting nearer to 0. This whole thing nearer to 0 means that for this part is very near to 0. You can consider this as 0. But what is the outcome here? Is it 0? No, because there is a negative x here. This one nearer to 0, but this one getting more positive infinity, right? In your mind. So getting bigger means that the x value getting very bigger, positive. So, but there is a negative here. So finally you are getting negative infinity. So this is the case here. So we consider the limits at infinity by using the concept of infinity. You must understand what is infinity. It's a very large number. It's undefined. We don't know what is that number. Alright. So that's all. Okay, this is the concept for limits at infinity, the first video. The second video, we're going to use this concept to evaluate a more complicated limits.